गुड मॉर्निंग एवरीवन। कैसे हैं आप सभी? गुड मॉर्निंग सूर्य कुमार, अंकिता, स्वाति। हाउ आर यू? हाउ आर ऑल ऑफ यू? I am sure that all of you are doing very well. I am sure that all of you have seen all the lectures in this series. Okay, we have completed types of symmetry operators. We have also completed properties of symmetry operators. In types of symmetry operators, we have studied 5 different types of symmetry operators, which are rotation, proper rotation, improper rotation, then reflection, then inversion, and then identity. Okay, and we have seen various properties of these symmetry operators. We have seen transformation of atomic coordinates, what happens to an atom at xyz position when we apply each of these symmetry operators. We have also seen what powers of these symmetry operators give. We have also seen what products of these symmetry operators give in the second class, which is the symmetry operator properties. Okay, good morning, Bhargavi. Daneshwari, homework answer is not C1. Homework answer is not C1. We will discuss the homework answer also, but it is not C1. Okay. All right. Good morning, Bhargavi. Then we have studied what point groups are, essentially what makes a collection of symmetry operators as a group. There are 5 different things, either commutative or non-commutative, secondly associative, then closure, reciprocal rule, and presence of identity element. Okay, so these 5 properties make a group, and there are many collections of symmetry operators which we call as point groups, and these point groups have or these point groups will describe various types of molecules with different types of symmetries. Okay, and in the last session what we discussed was we have discussed what point groups are. We have also discussed how to identify these point groups based on 4 different questions: whether it is a linear molecule, whether it is a molecule with rotational symmetry, whether it also has perpendicular perpendicular rotation symmetries, whether it also has more than one principal axis. Okay, so all of these are questions that will help us identify the various point groups. And then you have low symmetry point groups. Okay, and then you have low symmetry point groups. Low symmetry point groups are essentially point groups which do not have any rotational symmetry, which is C1, Ci, and Cs. Also, we have some point groups which have rotational symmetry but still comparatively have a lesser number of symmetry elements, namely Cn, Cnv, Cnh, and S2n. Okay, so the maximum order in these point groups is 2n, which is for CNH, CNV, and S2n point groups. Okay, so all right. Okay, so in today's class we are going to see what high symmetry point groups are, mainly point groups from the D category, and point groups which are tetrahedral, octahedral, icosahedral, and linear molecules, which are special symmetry point groups. Okay, good morning, Megha. Good morning. Okay, so before we continue, I want all of you to, as usual, share the link of this session on your WhatsApp status, on your social media, or simply go and tell your friends to join. You can just call them up and ask them to join this session for a very simple language discussion of group theory, especially high symmetry point groups. Okay, so we are going to discuss these 3 types of point groups: point groups which belong to the D category, point groups which belong to the tetrahedral, octahedral, icosahedral category, and linear molecules. So essentially these 2 types of point groups, they are special symmetry point groups. Okay, point groups with special symmetries, that is point groups which have more than one well, this is so tetrahedral, octahedral, icosahedral, they have more than one principal axis, whereas linear molecules have only one principal axis, but they are linear in nature. All right. What is the point group of pen? This pen, different pens can have different point groups. So for example, this pen has a reflection symmetry, so this will become CS. Okay, but if you have a perfectly cylindrical pen, okay, if you have a perfectly cylindrical pen, then we'll look at then it would be something similar to a linear molecule. So we'll have a look at that when we look at linear molecules. Okay, Megha. So this pen is not a perfectly cylindrical pen. It also has two buttons here, which means this will have a point group of CS. Okay, this will have a point group of CS. Okay. Now the homework question. What is the point group of this molecule? What is the point group of this molecule? Now I can draw this molecule like this also. I can draw this molecule like this also. So you have two hydrogens here, and then the part below, okay, here you have, if you have H coming out, then you will have Cl, sorry, if you have Cl going behind the plane, then you have H coming out of the plane, and if you have Cl coming out of the plane, then you have H going behind. Okay, so this is the molecule that we discussed yesterday. This molecule will have a C2 axis that passes through this. This molecule will have a C2 axis that passes through this carbon atom. Namely, if you look at this particular point and the center of the bond in front, then you will have a C2 axis that looks like this. Okay, then you have a C2 axis that looks like this. How is this the C2 axis? Look at the two hydrogens, they are rotated around each other, whereas this Cl, if you remember the trick that we discussed last time, whenever you have something that is similar to N, S or Z, whenever you have something similar to N, S or Z, you tend to have a C2 axis there. So this is the C2 axis. But now if you try to find out any symmetry, if you try to find out any mirror planes, reflection planes, you won't find any reflection planes, which is why this is a non-linear molecule. This is a non-linear molecule with a rotational symmetry, but no perpendicular C2 axis, no reflection planes, which means this point group will be C2. Okay, which means this point group will be C2. Is this clear to all of you? Is this clear to all of you? Is this clear to all of you? Okay, so the point group is C2. The point group is C2. Okay, clear? Ankita, Swati, Surya Kumar, Dhaneshwari, Megha, Bhargavi. Is this clear to all of you? Okay. Okay. If you like, if you have liked this example, please like the session also. All right. If you have liked this example, please like the session also, and share with as many of your friends as possible. Okay. Now let's look at the different point groups. Which point groups have we studied? So we have studied these 3 point groups. We have also studied these 3 point groups. In today's session, we are going to look at these 3 point groups, DN, DNH, DND, and we are going to look at this entire set of special symmetry point groups. Okay, and then we are going to look at this entire set of special symmetry point groups. Okay. So does anyone remember what the point group R denotes? Does anyone, can anyone give me an example of the point group R? Can anyone give me an example of a molecule which belongs to the point group R? We have discussed it in the 2nd class, if I am not wrong. Can someone tell me what is the point group? What molecule has a point group R? Can someone tell me what is the point group? What molecule belongs to R? Okay. Remember, this is a full rotation point group. What belongs to R? Okay, Megha, I am not asking you an example of D3H. I am asking you an example of R point groups. Okay. Which molecule belongs to the R point group? Remember, this is only spherical molecules. You only have spherical molecules here. So can you give me an example of a spherical molecule? Can you give me an example of a spherical molecule? Can you give me an example of a spherical molecule? Yes? No? No one? That's strange. There is only one type of a spherical molecule, which is a monoatomic molecules, which is helium, neon, argon, krypton, xenon, and radon. Okay, no other molecules are monoatomic. Okay, no other molecules are monoatomic. All the other molecules are either diatomic or crystalline, or in case of sulfur, for example, it is S8. Okay, octaatomic molecules. So only monoatomic molecules are belong to the R point group. Okay, the spherical molecules, which is called as the full rotation group, because only rotations are possible there. Okay, it's the full rotation group because only rotations are possible there. Okay, is this clear to all of you? Is this clear to all of you? Any doubts here? Any doubts here? Good morning, Maruti. Good morning. Okay, all right. I think everyone, no one has had their tea, their cup of tea or coffee today. Everyone is asleep. No one is answering me today. Everyone who is present in this session is asleep. I think all of you need some tea. Okay, let's go have some tea. Let's go have some tea. Okay, and let it be steaming hot tea. Let it be steaming hot tea or coffee, whatever you like. Okay, whatever you like, so that you are now extremely active and attentive and enthusiastic and energetic and ready to participate in the discussion in this session. Okay, this is not a lecture. I never call this a lecture. Lecture means only one person talks. No, I am not going to be the only person who talks. All of us are going to discuss point groups. Okay. Megha is asking, gate chemistry test series is available. Yes, Megha, gate chemistry test series is also available. It's there on our website. You can just give us a call and you will be given all the information. Okay, let's start. So if you remember correctly, how do we identify point groups? So the first question that we ask is whether it is linear. If a molecule is linear, you will get C infinity V and D infinity H point groups. So these two we are going to discuss today. Then if it is not linear and does not have a axis of symmetry, that we discussed yesterday, C1, Ci, Cs. If it is not linear, has an axis of symmetry but no perpendicular secondary axis, then it belongs to Cn, Cnv, Cnh, S2n. If it is non-linear, has a rotational axis of symmetry but also has perpendicular axis, perpendicular C2 axis, then we have Dn, Dnh, Dnd. Okay, for these rotational symmetry is present and perpendicular C2 are present. And then you have tetrahedral, octahedral and icosahedral molecules wherein rotational symmetry is present and overall they have more than one principal axis. Okay, they have more than one principal axis. Daneshwari is asking, what about fullerene? Fullerene we are going to discuss in today's class. Okay, I have brought that example in today's class. We are going to discuss what the point group of fullerene also is. Okay, Daneshwari, have patience. Fullerene is part of one of these point groups, the point groups that I have highlighted. Fullerene is one of these. Okay. All right. Let's start with the Dn point group. Okay, let's start with Dn point group. Okay, these are all high symmetry point groups. Even CN, CNV and CNH, we call them high symmetry point groups, but among them they have a lower symmetry overall. So let's start by DN. Now, what did we talk about? What did we discuss about the D category point groups? They have an identity operator, E is present. Then you have N minus 1 Cn that are present, and they also have N perpendicular C2 axis. They also have N perpendicular C2 axis. Okay, so how many symmetry operators are there? This is a total of N and this is a total of N. So the total number of symmetry operators, which is the order, that is 2n. The order of the Dn point group is 2n. Okay, the order of the Dn point group is 2n. Okay, Daneshwari, Megha, Maruti, Bhargavi, Surya Kumar, are all of you here? Ankita, Swati, are all of you here? Kavi is asking how to enroll for test series. Visit our website, or if you look at the topmost comment, there is a comment with a yellow colored chemistry CSIR net written there. Look at that comment. There is a pinned comment at the top. Just click on that comment. There is a Google form there. Just enter that Google form and you will know. We'll reach out to you with details of how you can enroll for the test series. Otherwise, the easiest way is just go visit our website and look for the online test series. You will find a way to enroll for it. Okay, Kavi? Our website is www.ifasonline.com. I'll write the website here, www.ifasonline.com. Okay, just go visit the website. You will find details of how to enroll there. I have tried there, but it is not working. Then you have done something wrong. Just call our contact number and they'll provide you details of it. Okay, good morning Komal, good morning Ankita. Okay, Ankita is here. I thought Ankita has just said good morning in the beginning and she has disappeared. Okay, all right, let's see. So Dn point group has these elements. Let's start by looking at the D3 point group. Okay, which symmetry elements will D3 have? So we will have E, we will have C3, and we'll also have C3 inverse. We'll also have powers of C3. Along with that, we also have 3 perpendicular C2. Now all of these C2 axes are equivalent. Okay, all of these C2 axes are equivalent. An example of this is cobalt ethylene diamine thrice, cobalt ethylene diamine twice, 3 plus. Okay, cobalt ethylene diamine twice, 3 plus. Okay, so Ankita is here. Good. Ankita is not answering, but she is here. Okay, cobalt ethylene diamine thrice. This will belong to the D3 point group. This will belong to the D3 point group. Okay, now where does the D3 C3 axis go through? So this is the cobalt. Okay, this is the cobalt, and if you look at these 3 nitrogen atoms, okay, you can join them. This is like a facial isomer. Okay, this is like a facial isomer. If you join these 3 these 3 nitrogen atoms, take the center and join the center with the cobalt atom, you will get a C3 axis. Okay, you will get a C3 axis. All right, and what are the C2 axis like? The C2 axis are center of this bond and the cobalt atom. This is one C2 axis. This is another C2 axis. And this is the third C2 axis. And this is the third C2 axis. Okay, this is the third C2 axis. Is that clear? Okay, so this is D3. And now because this uh, if you look at this particular molecule, this is ethylene diamine. Okay, so you have CH2 here, CH2 here, and then you have N here. Okay, so you'll have NH2 being written here, or you can also have an oxalate molecule, C double bond OO, C double bond OO, in which case rather than ethylene diamine twice, you can write this as oxalato thrice, and this will be 3 minus. Okay, you can write oxalato thrice and 3 minus. Okay, so now the oxalato is not in the same plane. Okay, the oxalate part, this is the oxalic acid oxalate ion, and this is not in the same plane. You can see that this is coming slightly above and this is below, which is why a mirror plane along this is not possible. Okay, a mirror plane along this is not possible, and which is why you won't have D3D or D3H point groups here. You will simply have a D3 point group in this case. Okay, is this clear now, everyone? Great. Okay, now the other examples of DN point groups are the twisted conformations or gauche conformations. Okay, the twisted or gauche conformations. So this is twisted ferrocene. Okay, this is twisted ferrocene. All right, and twisted ferrocene, because you have 5 carbon atoms here, this will belong to the D5 point group. This will belong to the D5 point group. Okay, is this clear to all of you? Is this clear to all of you? Yes. So if this is clear, I want you to answer one question. What is the point group of gauche ethane? What is the point group of gauche ethane? So I'll draw the gauche ethane structure. Gauche ethane structure will be like this. Okay, gauche ethane structure is like this. All right, what will be the point group of gauche ethane? Very good, Dhaneshwari, very good, Megha. Absolutely correct. The point group will be D3. The point group will be D3. Simply look at the rotational axis. So the 3C2 axis will be like this. This is one. This is another. And this is the third one. Okay, these three will be the C2 axis. Okay, and of course the C3 axis you already know, because it's a CH3 group, it will have a threefold rotational symmetry. Okay, Maruti, Ankita, Kavi, Komal, Surya Kumar, Bhargavi, are you understanding this? Simply say yes or no, so that I understand that you are understanding this, or say no if you don't understand this, if you need me to explain it better. Okay. Yes, no, only Dhaneshwari and Megha are here. Ankita has gone back to sleep, I think. Okay, then let's look at the next high symmetry point group. So the next high symmetry point group is D3H. Okay, now the D3H point group, will have various symmetry elements, like you have E here, you have N-1 Cn and N perpendicular C2. These are always there when you are talking about the D category point groups. Okay, when you are talking about the D category point groups, these are always there. Along with these, what would be present? Now, the moment you say DNH, the H signifies that there is a sigma H. Okay, so let's write sigma H here. Okay, so the sigma H is present. And the moment you have Cn and sigma H, you also have Sn. So we will have N-1 Sn that are also present. Okay, you will also have N-1 Sn that are also present. Okay, and some combinations of these symmetry elements will also give sigma v, in the DNH point groups. Okay, will also give sigma v in the DNH point group. So now what is the order? These are n elements, these are n elements, these together make n elements, and these make n elements. So what will be the order of this point group? Can someone tell me now? What is the order? What is the total number of symmetry elements in this point group? Can someone tell me what is the total number of symmetry elements in this point group? Very good, Dhaneshwari. Order is 4n. Order is 4n. Okay, order is 4n. Is this clear to all of you? Is this clear to all of you? Okay, excellent. So let's look at D2H point group. Okay, let's look at D2H point group. What will be the symmetry elements here? E will be there, C2 will be there. Then you have two perpendicular C2. You have sigma H. And because you have C2 and sigma H, you will have S2. And S2 means inversion. S2 means inversion. So inversion is also there. Okay. And which symmetry elements are missing? Now the symmetry elements that are missing are 2 sigma V. Okay. They are 2 sigma V. But actually you don't have both of them being sigma V. One of them is sigma V, the other one is sigma D. Okay, both of these mirror planes, both of these reflection planes are parallel to the principal axis, but one of them passes through more number of atoms, one of them passes through less number of atoms. Okay, so you have sigma V and sigma D in this case. Okay, so a total of 2 planes would be parallel to the principal axis. Half of them will be sigma V, half of them, the other half will be sigma D. Okay. Now, if you look at D3H, then what do you see? You have E, you will have C3, then you will also have C3 inverse because powers of C3 will also be there. Okay. Then you will have 3 perpendicular C2, and of course you also have sigma H. But this time, because of C3 and sigma H, you have S3. And the moment you have S3, powers of S3 are also there. So S3 inverse is also present. Okay, and now in D3H, you will have all 3 vertical mirror planes as sigma V. All 3 planes which are parallel to the principal axis, all of them will be sigma V itself. Okay, whereas if you now look at D4H, you will have E, you will have C4, C4 square is also there, C4 cube is also there, C4 cube is C4 inverse, and you will also have a C2 present here. Okay, you will also have a C2 present here because C2 is C4 squared. Okay, now as a result of these 3 rotational axes, C4, C4 inverse and C2, you will, and along with that sigma H being present, you will also have S4, S4 inverse, and S4, so this is S4 cube. You will also have S4 square, but S4 square is C2 itself. But this C2 combined with sigma H will also give an S2, which is the same as inversion. And then the moment you see D4H, okay, for D2H you had half sigma V, half sigma D. For D3H you had all sigma V. D4H again you have half of them sigma V and half of them sigma D. Okay, so what you have to note is when n is odd, you have n sigma V. Okay, and inversion is absent. Okay, but when n is even, you have n by 2 sigma V, n by 2 sigma D, and inversion is also present. Okay, and inversion is also present. So this is what you have to remember about DNH point groups. Okay, so if the value of n or the rotational symmetry is an odd number like d3h, d5h, then what you have to do is you have to have all sigma v. Okay, all the planes that are parallel to the principal axis have to be sigma v, and inversion is absent. But when n is even, like for example d2h, d4h, d6h, in that case half of the vertical mirror planes or the planes parallel to the principal axis, half of them are sigma v, the other half is sigma d, and here inversion is also present. Okay, actually this is not clear to me. What do you mean by this? Which part is not clear to you? Can you be more specific? Ankita, which part is not clear to you? Can you be more specific? Can you be more specific? Okay, so you have various examples here. The first one is ethene. This is C2H4, and this will belong to the D2H point group. Because all of these molecules are supposed to have a sigma H, a lot of these molecules will be planar. Okay, but there are some non-planar examples also, like for example this. Okay, so the second one is naphthalene. And this also has a point group D2H. This also belongs to point group D2H. So the axes are like this. Okay, even here the axes are like this, and of course there is a perpendicular axis there as well. Okay, Ankita, can you tell me which part you have not understood? I will try explaining it, or at least I will tell you which lecture to watch. D2H. Okay, all right. So then this molecule is PtCl4. PtCl4 2 minus. Okay, this is a PtCl4 2 minus tetrachloroplatinate ion. Okay, this is a tetrachloroplatinate ion. Because there are because there will be a C4 axis of symmetry like this. Okay, you will have a C4 axis of symmetry. This will belong to the D4H point group. This will belong to the D4H point group. Okay, then the next one that you have, this is eclipsed ferrocene. So in the last point group we saw twisted ferrocene. This is eclipsed ferrocene. Okay, this is eclipsed ferrocene, and let's look at eclipsed ferrocene more closely. You will notice that there is an Fe atom in the center. Okay, there is an Fe atom in the center, and you have C5H5. Okay, this is cyclopentadienyl anion. Okay, C5H5 anion, and you have hydrogen atoms attached to each of the carbon atoms. Now the hydrogen atoms are exactly on top of each other. Okay, the hydrogen atoms are exactly on top of each other. They are eclipsed. Okay, they eclipse each other, and because of this, when viewed from top, this will have a C5 symmetry. Because it is a C5H5 cyclopentadienyl anion, this will have a D5H symmetry. Okay, this will have a D5H symmetry. Is this clear? Is this clear to all of you? Okay, is this clear to all of you? Great. And this last example is an example of benzene. This is an example of benzene. The point group in benzene, all of you are absolutely correct. The point group of benzene will be D6H. Okay, you are absolutely correct. The point group of benzene will be D6H. Very good, all of you. Very good. So I am sure that you are understanding these point groups very well. Okay. Now let's go to the next one, which is the DND point group. Okay, the next one is DND point group. Which elements are present in the DND point group? Which elements are present in the DND point group? So you have E present here, then you have N-1 CN present here, then you have n perpendicular C2 present here. Okay, you have E n minus 1 Cn and n perpendicular C2 present here. Okay, and n perpendicular C2 present here. Then you also have, now because this is D and D, okay, there is no sigma h, the h is absent, which means horizontal planes are not there. You have D and D. The D stands for sigma D, that is dihedral planes, and you will see dihedral planes in this case. Along with dihedral planes, you also see Sn, which is improper rotations, but these are S2n. Okay, these are S2n rather than Sn. Okay, so D3D will have S6. Okay, D2D will have S2, S4. Okay, so these are improper rotations with a double symmetry than the rotation symmetry. Okay, so you have n S2n and you also have n sigma d that are present. You also have n sigma d. All the planes present here are dihedral planes. All planes passing through the or parallel to the principal axis are dihedral planes only. Okay, is that clear to all of you? Is that clear to all of you? This is the DND point group. Okay, this is the DND point group. Is this clear? All right. Now let's look at what you will have in D2D. So how many total symmetry elements does this have? How many symmetry elements are present? What is the order of this point group? What is the order of this point group? Yes, Bhargavi, Megha, Ankita, Surya Kumar, Maruti, Daneshwari. What is the order of this point group? What is the order of this point group? 4n. Very good, Megha. Very good, Megha. The order of this point group is 4n. The order of this point group is 4n. Okay, very good, all of you. Very good. Absolutely correct. Absolutely correct. Okay. Who all are missing here? There are many people who are attending this class but not answering. Komal is here, but Komal is not answering at all. Kavi has disappeared. Okay. Okay. So, let's have a look at the symmetry elements in D2D. So, D2D will have how many symmetry elements? Can someone tell me how many symmetry elements should we expect in the D2D point group? How many symmetry elements should we expect in the D2D point group? Can someone tell me? How many symmetry elements can we expect in the D2D point group? Can someone tell me? So because the order is 4n, can someone tell me what do you expect in D2D point group? Very good, 8 symmetry elements. Very good, 8 symmetry elements. So what are these symmetry elements? You will have E, you will have C2, you will have 2 perpendicular C2 as well. Okay, and then if you have C2, you will have S4. So you will have 2 S4, and the 2 S4 are S4 and S4 inverse. You will have S4 and S4 inverse. The square of S4. So all powers of S4 should be there. S4 raised to 1 is here. S4 raised to 3 is S4 inverse. But S4 raised to 2, okay, S4 raised to 2 is actually C2. Okay, S4 raised to 2 is C2. So then you don't have to write S4 square separately. And then you will have 2 sigma d that are present. You will have 2 sigma d that are present. So a total of 8 symmetry elements are present here, and the order of D2D is 8. Okay, then if you look at D3D, which symmetry elements are present? You will have E present here, then you will have C3, then you will have C3 inverse. Okay, you will have E, C3, C3 inverse. Good morning, Janvi. Good morning, Janvi. How are you? I hope you are doing fine. I think the sun is just rising where Janvi is, because she is showing me a picture of sunrise in 2 mountains. Okay, so I think the sun has just risen there. Okay, Janvi is late. That's okay. That's okay. We still have a lot to cover in this class. Don't worry. Okay, so then you will have three perpendicular C2 axis here. And now, because it is C3, what is the improper rotation that you will have? You will have S6 improper rotation. Okay, and because you have S6, S6 square is C3, S6 cube is C2. S6 cube will be inversion. S6 raised to 4 will be C3 inverse. S6 raised to 5 will be S6 inverse. Okay, and S6 raised to 6 is identity itself. So these these symmetry operators will be present as a result of S6. Okay, and then because it is D3D, you will have 3 sigma D directly. You will have 3 sigma D directly. Okay, so a total of 12 elements are present here. How about D4D? Which symmetry elements do you expect in D4D? Can someone tell me which symmetry elements do you expect in D4D? Janvi, Ankita, Megha, Dhaneshwari, Surya Kumar, Maruti. How many symmetry elements can you expect in D4D? How many symmetry elements are possible in D4D? Okay, Janvi watches the recorded sessions. I understood that, Janvi. I understand. Sometimes for some students, it won't be possible to attend the live class, but do watch the recorded class. As far as possible, try to attend the live class so that you can get your doubts resolved here, because it is very difficult to resolve your doubts when you are attending a recorded class. But otherwise, make sure that as far as possible you attend the live class rather than the recorded class. Okay, yes, very good. There are a total of 16 elements in D4D. Very good, Dhaneshwari, Megha, Bhargavi, absolutely correct. And they will be E, C4. You will have C4 inverse as well. You will have C2 as well. Then you have 4 perpendicular C2. Then you have S4, S4 inverse, and S4 square will be C2 itself. Okay, S4 square will be C2 itself. So there should be a total of 4 powers of S4, right? There should, sorry, not S4, S8 would be there. There should be a total of 4 powers of S8. So S8 is there, S8 raised to 7 is there. Now S8 cubed, okay, if you look at S8 cubed, that will be C4 cubed or C4 inverse into S8 cubed will be S4 inverse, if I am not wrong. So S8 cubed will be C8 cubed into sigma. Well, no, that will simply be called S8 cubed. That is also there, and S8 raised to 5 is also there. Okay, S8, S8 inverse, S8 cubed, and S8 raised to 5. All of these will be present. S8 raised to 4 will be C4. So that will be C2. So that is something that we have already written. And then you will have 4 sigma D here. You will have 4 sigma D here. Now let's write a few examples of each of these. A few examples of each of these. An example of D2D is the allene molecule. An example of D2D is the allene molecule. Now what is the allene molecule? You have cumulative carbon-carbon double bonds. Okay, you have cumulative carbon-carbon double bonds. Okay, with 2 hydrogens, and then you have perpendicular hydrogens present here. Okay, and then you have perpendicular hydrogens present here. Okay, so that is allene. Then in D3D, you have the chair form of cyclohexane. You have the chair form of cyclohexane, and that is D3D. Okay, so you know, all of you know what the chair form looks like. Okay, chair form of cyclohexane, that is D3D. And an example of D4D is sulfur. S8, that is an example of D4D. Okay, so also remember that all the staggered isomers, okay, staggered ethane, all the staggered isomers, they will belong to D and D point group. Okay, this is staggered ethane, this is staggered ferrocene, this is staggered ferrocene. Okay, these belong to the D and D point group. So this will be D3D and this will be D5D. Okay, is that clear to all of you? Is that clear to all of you? So these were the D category point groups. These were the D category point groups. Okay, is that clear? Yes, chair cyclohexane is D3D. Chair cyclohexane is D3D. Okay. All right. Before we go ahead, before we look at the special symmetry point groups, I simply want to update you on what all is going on in IFAS. So there is a special live batch that is starting for CSIR Net 2024. This will be a Hindi plus English mix batch. Okay, the teachers will be speaking in Hindi, but the notes are in English. Okay, so you will understand everything, whether you are a Hindi speaker or an English speaker, you will understand everything that goes on there. All right, and this special live batch is starting on the 18th of December. Okay, this special live batch is starting on the 18th of December, which is this Monday. So all those who are planning to enroll for the CSIR Net June 2024 batch, make sure that you enroll in this batch. You will get an extra 1 month as compared to all the competitors, all your competitors, meaning all your batchmates who are taking this exam, and you have to score higher than them to get a better rank. So remember, the earlier you start, the better. Along with that, for those who are aiming for the December 2023 exam, there is a special test series for all of you. We have reduced the price of the test series to just 199 rupees. Okay, and enroll in this test series as early as possible. There are topic wise mock tests there, as well as full length mock tests in these tests. Okay, and plus there is a detailed video solution available for each and every test. Okay, then you also have we are also going to be starting special prime classes. Okay, right now they are only going on for life science, physical science and mathematical science, but we are going to be starting special prime classes on our IFS app. These prime classes are absolutely free live classes on the IFS app. So so that you get to know what our features are. Our app is one of the best apps available in the market for online education. So we want you to explore our app, and these prime classes will give you these prime classes will give you a good chance to explore it. Okay, and finally, there is a special live lecture series that you are already attending. Please tell your friends about this lecture series. We are discussing group theory. After that, we'll also, once we complete group theory, we'll also look at organic chemistry and inorganic chemistry lectures. So make sure that you are attending all of these classes, but apart from that, telling your friends about these classes also. Okay, because in IFS, we have taught in Hindi for the last 4 to 5 years. Now we also want to have lectures for students who are more comfortable in English than in Hindi, and for them this lecture series is going to be one of the best lecture series to learn chemistry. Okay, all right. And then the other thing that I want to remind you is that there is a flat 50% off going on for the IFS study material. This is a complete set of 8 theory books. Okay, inorganic chemistry, organic chemistry and physical chemistry. 4 practice question books and 1 PYQ solutions book. Okay, this is a book with last 13 years previous year questions sorted topic wise, meaning you will get for example all group theory questions in only one chapter. You don't have to search through every paper to find group theory questions. All of them will be available in only one chapter, and then all of these questions appear with detailed explanations of how to solve them. Okay, all right. Now let's look at, so before that let me just remind this part to you again. There is a flat 50% off. This offer is only valid till 31st of December, only in this month. This offer will disappear in the next month. Make sure that you purchase this study material right away so that you can avail a flat 50% off. This entire set of 13 books is available at you can see here, or maybe you cannot, it's hidden behind the podium, but you will get the entire study material set for rupees 5250 only at a flat 50% off. Okay, all right. Now let's look at some molecules with special symmetries. There are 3 point groups: TD, TH, T. Okay, the TD, that is the tetrahedral point group. This is one of the most important point groups. This is the only one that is usually asked. The other TH and T point groups are not asked because the molecules there are very complicated molecules. So tetrahedral point group, which types of symmetry elements will this have? So because these are special symmetry point groups, you will have more than one principal axis. Okay, so tetrahedral has C3 axis as the principal axis, and you have a total of 8 C3 axis for tetrahedral point groups. Okay, you have a total of 8 C3 axis for tetrahedral point groups. Okay, so each CH bond, this is for example methane. This is for example methane. Each CH bond is a C3 axis, and because C3 is there, C3 inverse will also be there. Powers of C3 will also be there. So total 4 CH bonds, meaning 4 C3 axis. And for each C3 axis, there is a C3 inverse also, meaning a total of 8 C3 axes are present. Okay. Along with that, there are C2 axes. There are 3 C2 axes that are also present. Okay. Now these C2 axes, so the C3 axis were the CH bonds. Okay. Each of the CH bond was a C3 axis. The C2 axis will be something that bisects the HCH dihedral bond, HCH bond angle. Okay, so the C2 axis will be something that bisects the HCH bond angle. Okay, and then along with that, you have some sigma D, 6 dihedral planes. These are also planes that bisect the HCH bond angle, but these are also planes that pass through the HCH bond angle. Okay, and you also have 6 S4 symmetry elements. You also have 6 S4 symmetry elements. These symmetry elements will be, so essentially you will have S4 and S4 inverse as well. These are the elements that have the same axis as the C2 axis. Okay, so overall, the order of tetrahedral point group is 24. The order of tetrahedral point groups is 24. If you remove the dihedral planes and if you add a horizontal plane, if you remove the dihedral planes, what you will get is just T. Okay, T has an order of 12, whereas if you add horizontal planes again, you will have TH with an order of 24 again. Okay, now these two are, as I said, not very important. You can just remember the order of these point groups. You don't have to remember details of these because these are almost never asked in the exam. Okay, so you don't have to worry about the T and the TH point groups. Okay, so a few examples are CH4. This is actually neopentane. CH34C. Okay, this is neopentane, which is CH34C. This is also tetrahedral point group, and this is actually a tetrahedron. This is actually a tetrahedron. Okay, this is actually a tetrahedron. What are the fees of CSIR net? Sapna, you can simply visit our website. Our website is www.ifasonline.com. Okay, our website is www.ifasonline.com. Just visit this website. Once you visit this website, you will go to the CSIR Net chemistry section and look at the live batch. Okay, if you look at the live batch, you will see what the fees are. Remember that there is a discount going on. There is a special discount that is going on for this batch. Make sure that you avail that discount as well. Okay. All right. So this is the tetrahedral point groups. Now let's look at another set of point groups, which is the octahedral point groups. The octahedral point groups OH and O. Okay, the octahedral point groups are OH and O. Now this is what an octahedron is. Okay, this is what an octahedron looks like. Okay, octahedron has 8 faces and 6 vertices. Okay, octahedron has 8 faces and 6 vertices. Okay, an octahedron has 8 faces and 6 vertices. So this is any octahedral complex mx6. Okay, any non-substituted octahedral complex mx6. However, without Jahn-Taylor distortion. Okay, mx6 without JTD, Jahn-Taylor distortion. These will be octahedral complex. These will belong to the OH point group. Okay, so what symmetry elements does OH point group have? Now again, as I said, there are more than one principal axis. So the octahedron will have identities there, and then each mx bond. Okay, each mx bond is a C4 axis, and there are there are a total of 3 mx bonds. So you'll have 6 C4. Okay, 6 C4, and in fact C4 square will also become C2. So you'll also have some C2 axis. You will also have, I am not writing the exact number, because if I write the exact number, I am sure that you will think that we need to remember the number of these axes. You don't. Okay, just remember there is a C4 axis, there is a C3 axis, there are C2 axis. There is there are many mirror planes. These are dihedral mirror planes. Okay, then you also have S4, you also have S4, you also have S3 present, and you also have inversion present. Okay, you have S4, S3 and inversion as well. All right, and inversion as well. So a total of 48 symmetry elements are present in the octahedral group. A total of 48 symmetry elements are present in the octahedral group. Okay, and if you remove the sorry, this is not sigma D, this is sigma H. You'll also have sigma D along with this. Okay, let me write sigma D as well. So sigma H are there, sigma D are also there, and this is the octahedral point group. Okay, this is the octahedral point group. If you remove the H, okay, if you remove the H, the sigma H, then you end up with O. Here again, the only thing that's important is what the order is. The order is 24. Just remember that. You don't need to remember anything else. Okay. AKD is crying. He is saying that his yesterday's question is not being answered for some reason, but he is not trying to remind me what his question was. He is not trying to tell me what his efforts were in trying to figure out the answer to the question by himself. So unfortunately, I don't. Oh, that question. I remember AKD. You asked this in the exam mapping session. That's why I didn't remember. I remember this. Okay, let's solve this here. Let me complete the group theory, the point groups that we are discussing, and I'll solve it right now. Yesterday, I think a lot of students were waiting for the inorganic chemistry session to start, but I'll solve it right now. So I'll tell you the answer. I think I have told you how to solve it yesterday. Use something called as the Stirling's approximation. And because you are asking it again to me, it means that you have not at all attempted to solve it. You have not even Googled what Stirling approximation is. So that's a very bad habit in a student, not to try things out on their own, relying on the teacher to provide a ready-made answer. So that is not something that is going to help you. But because you're insisting, I'll still solve it. Okay, I'll still solve it using this. But until then, I want you to go ahead, Google what Stirling's approximation is, and using Stirling's approximation, I want you to try this out first. Okay, then I'll solve it. But I am absolutely, as a teacher, absolutely against spoon feeding. Okay, spoon feeding only helps little children, little babies who can't do anything. You are not a baby anymore. You are going to become a PhD student. You are going to become a teacher. You have to try this out on your own first, and when you can't solve it, then ask us. Okay, so I told you how to solve it. It's using Stirling's approximation. Go ahead, give it a shot. Otherwise, at the end of this class, I'll try to tell you how to solve it. Okay. All right. So the octahedral point group. Okay. So octahedral point group is as a order of 48, and if you remove the sigma h, the OH, the H disappears from the name of the point group also, and you get O. Okay, that is octahedral. Okay, AKD. Is that okay? Are you going to try it on your own, or are you going to wait for me to spoon feed you the answer? AKD, at least say that you are going to try it on your own. How am I going to check whether you have tried it out or not? At least say that, at least tell me that you have the right attitude. Okay, good. Good. AKD, try it out on your own first. And when what we are discussing is over, I'll ask you what you have tried. Tell me in the comments, and then we'll see. Okay. All right. Then the last of the point groups are icosahedral point groups. IH stands for icosahedral. Okay, someone was asking me, what about fullerene? What about fullerene? So this is an icosahedron. This is an icosahedron. Okay, what does an icosahedron have? It has 12 vertices. It has 12 vertices and 20 triangular surfaces. 20 faces, all of them are triangles. 20 faces, all of them are triangles. Okay, and when you replace these 12 vertices by 12 pentagons, and if you replace these 20 faces by 20 hexagons, you get this. This is C60, which is fullerene. Okay, this is C60, which is fullerene, which has 12 pentagons and 20 hexagons. Okay, 12 pentagons and 20 hexagons. This is fullerene. Okay, this is fullerene. Okay, so this is made up of, this is the icosahedral point group, IH. Here again, you don't even have to remember all the symmetry operations. Just remember that E is there, C5 is there. Okay, E is there and C5 is there. Along with C5, there is a C3 also that is present, I think. Then there will be a C2 that is present. Then you will have sigma H. You will also have, I think, sigma D. You will have S5 that is present, if I'm not wrong, or S10. S10 will be present. Then S6 will also be, I think, present. And then you also have inversion in this. Okay, so a lot of symmetry elements, a lot of different symmetry elements. The order is a total of 120. The order is a total of 120. If you remove the sigma H, which is the horizontal mirror planes, what you get is I. This is an order of 60. Okay, this is an order of 60. Okay, is that clear? So this is icosahedral point group. This is the icosahedral point group. Okay. Then now let's look at linear molecules. So these are special symmetry molecules, but these are linear molecules. Okay, when you have linear molecules, you will have a C infinity axis. So E will be present. You will have a C infinity axis, and you will have infinite such C infinity axis, because if C infinity is there, C infinity square is also there, C infinity cube is also there, raised to 4, raised to 5, raised to 6, up to infinity. So you'll have a total of infinite C infinity axis. You will also have infinite mirror planes, which are vertical mirror planes. Okay, you will also have infinite mirror planes, which are vertical mirror planes, but no other symmetry element. Inversion is absent, and improper rotation is also absent. As a result of which, so of course the order is always infinite, you don't even have to worry about the order, but because sigma mirror planes are absent or sigma h is absent, what you will notice is that heteronuclear diatomic molecules and linear unsymmetrical molecules, these are the ones which belong to the C infinity V point group. Okay, so can someone give me examples of heteronuclear diatomic molecules? What are some of the heteronuclear diatomic molecules? What are some of the heteronuclear diatomic molecules? So I'll write the first ones here: HCl, HBr, HI, HF. So I'm sure that all of you are thinking of these. Apart from these, are there any other heteronuclear diatomic molecules? Apart from these, are there any other heteronuclear diatomic molecules? Yes, AKD, Sapna, Ankita, Bhargavi, Dhaneshwari. It's your turn now. HCN is not diatomic. Dhaneshwari, HCN has 3 atoms, H, C and N. So that's not diatomic. Janvi, Megha, Suryakumar. Any heteronuclear diatomic molecules? Very good. NO and CO. NO and CO, nitrous oxide and carbon monoxide. Okay. All right. Any other heteronuclear diatomic molecules? Till you remember, try to tell me linear unsymmetrical molecules. So that's HCN. That is HCN. Anything else? Anything else? So Prahlad, I have written HCl, HBr, HI, HF. I know that those you are going to tell me for sure. So I have already written those. Anything else? Anything else? Anything else? No. Okay. Linear unsymmetrical molecules. HCN is one example. COS, that is another example. Okay. So carbon oxysulfide. There is a CO2. In place of CO2, you remove one oxygen and you replace it by sulfur. So that is COS. Okay, that is COS. You will also have N2O. Okay, N2O is also a linear unsymmetrical molecule. Okay, N2O is also a linear unsymmetrical molecule. Okay. Then last point group that we have to see is D infinity H. Okay, D infinity H, because it's a D category point group, you will have perpendicular C2. So you have E, you have infinite C infinity axis, you have infinite perpendicular C2 as well. Okay, and there is a sigma H present. There are infinite S infinity also present. There is an inversion that is also present. There are infinite sigma V also that are present. Okay, so all possible symmetry elements that you can think of: identity, rotational symmetry, reflection symmetry, improper rotation symmetry, inversion symmetry, all of them are present in D infinity H. Okay, all of them are present in D infinity H. Got it? Okay, Prahlad has given us a very good example, that's I3 minus. But I think I3 minus, is that a linear molecule? Okay, yes, I3 minus is a linear molecule. That will be an example of D infinity H. Okay, because it's symmetrical. I3 minus is symmetrical. So it will be an example of D infinity H. Okay, so here also the order is infinite. You don't have to worry about the order. And you will have homonuclear diatomic molecules. Homonuclear diatomic molecules and linear symmetrical molecules. Linear symmetrical molecules. Okay, homonuclear diatomic molecules. Can someone give me examples of homonuclear diatomic molecules? So you have H2, N2, O2, F2, Cl2, Br2, I2, etc. And you can have many more. I think these are the most common. These are the most common. Okay. Similarly, how about linear symmetrical molecules? You can have CO2, you can have C2H2, that is acetylene, okay, and I3 minus that Prahlad suggested. I3 minus will also be a linear symmetrical molecule. Okay, I3 minus will also be a linear symmetrical molecule. Okay, so these are all the different types of point groups that are observed in different types of molecules. Okay, is this clear? So if you have liked this class, make sure that you like the video also. There is a like button, press the like button. Don't simply like the class and keep it inside your mind. It's very bad for your health to keep your feelings deep inside you. It's always good to express those feelings. One way to express those feelings is by hitting the like button, and a better way of expressing those feelings or showing us support is by sharing the video, sharing the link of this video on your if you're okay with it, if you're comfortable with it, simply share it on your WhatsApp status or some other social media, or simply go and tell your friends. But most importantly, make sure that you are liking this session, you are pressing the like button on this session, because it's important for us to get motivation from you, so that we keep bringing these lectures, these sessions for you. And the more support you show us, the more English lectures, English classes we will keep bringing for you. Okay, so remember this particular table. I think we have talked about this table many times. So this table will help us identify the different point groups. Okay, so all right, this is now the test series was priced at 500. Now this price has gone down to 199 only last 2 weeks are remaining for our exam. So the test series is now available only at 199. Anyone who wants to avail this test series, please go ahead and take an admission. There is an English version test series also. Make sure that you ask for the English version test series rather than the Hindi version test series. All right, and this has a lot of topic wise tests as well as a full length mock test, and all of these are going to help you prepare for the CSIR net exam, along with detailed video solutions of each and every question appearing in the test. Okay, so more than 1000 IFAS students have qualified in the June 2023 exam. We want all of you to also be part of this revolution in CSIR net education or PhD entrance educations. So make sure that you enroll as early as possible. There is also some free content available on our IFAS website, which is all the last 13 years previous year question papers. All last 13 year previous year question papers, we are making them available to you free of cost in PDF format on our IFAS website. So go to the website, register, explore the website. There is a lot of free content available there for CSIR net as well as GATE as well as SET exams as well as BARC as well as TIFR. So make sure that you don't miss this opportunity. Okay, so all of this is also available on the IFAS app. You can download the app and you can register same way you register on your on the IFAS website. You can also register on the app and you can get all of this free content there. Okay, so thank you for attending this session with me today. We are going to meet again later on in one more session of a lot of more sessions of group theory. In the next session, what we are going to talk about are character tables and various applications of group theory of point groups. We are going to talk about polarity. We are going to talk about chirality. So make sure you do not miss those sessions. Make sure that you put up a reminder for 9 o'clock or even 8:30 in the morning, so that you wake up, you have your cup of coffee and are ready for group theory lectures. Okay, so thank you for watching this. Goodbye everyone, and happy learning to all of you.